So we know we can use the cross method or the tic-tac-toe method to factor a quadratic trinomial, but what if we have a quartic instead, aka x to the fourth power? Well, right here, let me show you guys the double cross method or the double tic-tac-toe method. First off, I will have to tell you, this right here can be factored as a product of two irreducible quadratic. And if you use the factorization wrong, then it's not going to work. But let's go ahead and check this out. First, I will start with 5x to the fourth power and just break it apart. Well, 5x squared times x squared is the only way to get 5x to the fourth power, so that's it. Thankfully, this is not like 8 or 6, otherwise that will be, yeah, a lot more difficult. Alright, anyway though. Then I will go to the x squared term, and you have to be careful here. You cannot just look at negative 11 and say 1 and negative 11 or negative 1 11. No. Right here, we can only put down some number a times x and then b times x. Because when you multiply this and that, this is not the only way to produce the x squared term. We will also have to consider the 5x squared times constant here, right? So we really have to put down a and b right here. And what do we do next though? Well, here this is the first time we are using the cross method or the tic-tac-toe method. We do this times that, which we can get 5bx to the third power, and we do this times that, we get ax to the third power. These are the only two ways to produce the x to the third power term, all right? So that means we must have this coefficient plus that coefficient equals that coefficient, which we know we must have a plus 5b equals negative 26. Yes, we're going to solve a system equations later on. Yeah. But anyway, come here. Now we have 6. This is crazy. We are just going to break it apart, and then it really depends on where we put it, right? So let's just hope for the best, I will say. This is not easy, all right? So let's just go ahead and try 2 and 3. And let's do this times this times this. And we will get 2b x, and this times that is 3a x. So same idea. These are the only two ways to produce the x term. So we must have this plus that equals that. So we have 3a plus 2b equals negative 10. And the reason I put this down in red is because I am not sure if they will work or not. And now let's just go ahead and solve for this real quick. So perhaps I'm just going to multiply everybody by negative 3. So this is negative 15. And negative 3 times this, that's a pretty big number. 28. Cancel. And then we have negative 13b equals 68. I don't think this works, because I should have told you guys that the coefficients are integers. So you see, if we don't end up with an integer, then no good. Let's just try another one. So maybe I just put down the wrong order. So, and of course, in order to make this fair, I will have to say, hey, they can all be like factored in terms of like a quadratic times a quadratic, and then all integers, right? So that's how we can make it more fair. But well, we continue here. So this right here is 2a plus 3b. All right, let's try this again. And we'll multiply everybody by negative 2, and that will be positive 52. Yes. Combine, this is going to be negative 7b equals 42. So b could be equal to negative 6. And if b is equal to negative 6, put it here, that's negative 30. So that means a has to be equal to 4. Just do this in your head, right? Okay, so right now we are saying that this is negative 6 and this is 4. And what I will do is I will just multiply this and that, which I will get negative 24x squared. And then we will have to do this times this. That will give us plus 10x squared. And then take this times that. That's plus 3. Hey, it works. I didn't prepare this, okay? Well, I kind of did, but like I forgot. Yeah, anyway. Yes, 13 plus this is negative 11 x squared. We know the answer is just this, that, and then this, that. So, ladies and gentlemen, this right here, I'll just say the answer is equal to 5x squared plus 4x plus 3 times x squared minus 6x plus 2. Yeah, cool. All right.